Hello and welcome. So we're given that we have a parallelogram A, B, C, D, and it says, all right, so we have angle CDA. Now, that doesn't mean that angle C, angle D, angle A are all equal to each other. What this is a specific notation that says, okay, angle C to D to A. Which angle is that talking about? The only angle between C, D, and A, that's that single portion right there. Okay, that is angle CDA down there. So then we're told that is the negative 7c plus minus 55. Okay, we're also told that we have angle A, B, C, which is the angle in there. Well, that's going to be that angle right here. Okay, and we're told that that one is c squared plus 9c. Alright, so when we're looking at this one, then you'd say, okay, well now you have your two angles. How do they relate to each other? Well, we know two properties when it comes to angles and parallelograms. The first property is that we know that angles that are directly opposite of each other are going to be congruent. That means that your angles right here, CDA and ABC, they have to be congruent because they're opposite of each other. What if they weren't? Right? What if instead we had, say, maybe this angle over here, an angle B? Well, these would then be adjacent and they would add up to 180 degrees. Okay? So if they're adjacent, they add up to 180, but we don't have adjacent angles here. We have opposite angles, and those are congruent. Which means that your negative 7c minus 55 equals c squared plus 9c. There you go. That's the relationship. They're congruent. That means they're equal to each other. Set them equal to each other. Now you have an equation. You can solve this, right? As soon as you see a c squared, hopefully bells are ringing that you have one of three options. You can either 1, factor, 2, use quadratic formula, or 3, complete the square. Now, personally, I like factoring. Let's do it. Okay? So to factor, you want everything on the same side, so you can either move this to the left or move this to the right. Doesn't matter. No, you will end up with the same answer either way. Because I like keeping my c squareds positive, it makes my life easier. I'm going to move everything to the right. So I'm going to add 7c and add 55. Okay, so now those cancel, you're left with 0 on the left. On the right, we have c squared plus 16c plus 55. Because that's just going to be 9 plus 7, 16. Okay, so to factor this, you'd say, all right, middle number, that's a 16. Your first number's 1. Last number is a 55, right? So add to 16 and multiply to 55. There are only two numbers that do it, 5 and 11. Right? 5 plus 11 is 16. 5 times 11 is 55, which means that you have your numbers. So then you'd only have to double check from there and say, all right, now you have the 1 out front, which means your shortcut, totally a thing here, and you have 0 equals just your two numbers, c plus 5 and c plus 11. To finish solving, set them both equal to 0. So that means we got two answers. The first one, we subtract 5 to both sides, so c equals negative 5. Next one, subtract 11 to both sides, you get negative 11. So we have c equals negative 5 and negative 11. Alright, so now you got to plug in your answers. You can't just say, whoops, that's supposed to be a c down there. Okay, you can't just like plug it in and be done with it. Alright, you do have to double check that your solutions are even valid, so you got to plug them in. So you say, alright, so now we say we have two values of c, plug them back into your originals, make sure they work. How you double check is that we should be getting only positive numbers back when we plug these in. Because negative numbers don't make sense if you plug it in. Because they're geometric figures, while negative angles are possible, they're totally valid, right? In a geometric figure, negative angles don't make a lot of sense. So, let's start with negative 5. So this first one, if we plug in negative 5, into our c, we get negative 7 times negative 5. Well, that's positive 35. And 35 minus 55, that's negative 20. Now, negative 20 is a number that doesn't make sense in this geometric figure. That's not going to work out, which means that negative 5, not an answer we can use. Okay, now try negative 11 out. Let's see if it gets any better if you change it up. So we choose negative 11, plug it in. So negative 7 times negative 11, that's positive 77. Minus 55, positive 22. That one works out just fine. Perfect. Let's try the other one. So this one we get c squared, so negative 11 squared. That's going to be 121. Minus 9 times c, that's so 9 times negative 11, that's negative 99. 121 minus 99, that's still going to give you positive 22, which means that we're getting the same number, which as we should, we know they're congruent, they should be equal to each other, but we know they're positive numbers, which means that negative 11 actually works out as your solution. Now what happens if it hadn't? What if it had failed this second one but not the first? In which case, it only has to fail once for you to take it out as a solution, which means negative 11 wouldn't have worked. And both of your solutions failed, which means a solution to C does not exist, is what you would put inside of the answer box. Okay, now, what if they both worked? That's totally fine as well. In which case, negative 5, comma, negative 11 would have been your answer. Okay, and that's it. Nothing more to do there. Thanks for watching.